Hello, today we will be solving the circuit using the node voltage method. So the node voltage method is a great way to solve a circuit with unknown voltages. So let's start off with naming our nodes. So we have V1 here and V2 here. They're both unknowns. We know that this node is 5 volts because the voltage difference between the positive voltage side is 5 volts minus the ground, which is 0 volts. Down here, this is the ground, or this is the ground voltage, the ground node, which is 0 volts, and that equals 0. That equals 5 volts. So that node is 5 volts. Same thing here. We know that this node is 3 volts because the positive side of the voltage is 3, while the negative side down here is 0 volts. So 3 minus 0 is 3. Okay, I'm gonna start off with highlighting our nodes so it's easier to see. Alright, there are my nodes. So a general rule is that you must have n equations for n unknowns. Since we have 2 unknowns, we need to have 2 equations. So how do we get those equations? So let's start off with node V1. So since node voltage method is derived from KCL, or Kirchhoff's current law, and Ohm's law, we'll be using those two to help us out. So KCL states that sum of all currents out equal to 0. And Ohm's law is the relationship between voltage equals current times the resistance. So at node V1, we can assume that the currents are coming out like so. So this one right here is going across this resistor to the 5 volts. Oops. So first, we're gonna rearrange this to I equals V over R because we're trying to find the current. So V1, since the currents are coming out of node V1 to 5 volts to that node right there, we will be subtracting it as like this. So V1 minus 5V, and then we have our resistor in the bottom, and that one, it looks like it's gonna go over our 10 ohm resistor. So 10 ohms goes right there. So, and KCL is the sum of all currents. So you're gonna add. Now we look at the next one. It's V1 going to ground node. So it'll be V1 minus 0 volts on the numerator. And then the denominator is 20 ohms. And then our third one, it's V1 going across the 30 ohm resistor onto node V2. So that'll be V1 minus V2 in the numerator, and then over the 30 ohm resistor to set equal to 0. So that's our first equation. We remember we have two unknowns, so we must have two equations. So now let's evaluate V2 right here. Let's assume that our currents are coming out of this node as well, so that everything stays positive and constant. So at V2, again, we'll be using I equals V over R. Alright, so we're going to look at this side first. V2 is going across the 3 ohm resistor to V1. So the numerator will be V2 minus V1 over 30 ohms plus this side down here. V2 is going across the 40 ohm resistor to ground node, which will be V2 minus 0 volts in the numerator over 40 ohms. Next, we can see that V2 is going across the 50 ohm resistor going to 3 volts. So it'll be V2 minus 3 volts over 50 ohms. Set that equal to 0. Yep, I got that right. That's our second equation. And then to solve for this, it's pretty much basic algebra. We're gonna take our first equation, we're trying to find the voltage values for V1 for our first equation. Okay, so the denominators, they have lowest common multiple of 60. So we're gonna multiply all of these fractions by 60, and then 60 divided by 10 times 60 divided by 20 is 3 times the numerator, and 60 divided by 30 is 2 times the numerator. Then you distribute the outside to the inside times, I'll just put it really quick, that's just 0 plus 2 v1 minus 2v2 equals 0. Okay, so now you combine like terms. So this guy and this guy, combine it. 6 plus 3 is 9 plus v1, then minus 2v2. And then I guess this will be our constant value. So we're going to move it to the other side. And then that'll be our first equation. Next, we're going to use, what was it? System of algebraic expression or something. I don't remember what the term is called, but we're going to look at equation 2. Okay, so we're gonna want to find our lowest common multiple for the denominator, which in this case it'll be $600. Okay, I think that's a little too big, but once it's 600, it's just a whole number. Okay. Oh yeah, 600 divided by 30 gives you 20. 600 divided by 40 is 15. And then 600 divided by 50 is 12. Okay, and then you distribute outside of your parentheses to the inside. It gives us this. Next, you combine like terms. So combine v2 together, or I'll put, and then combine v2 together. And then our constant is 36. So we move that to the other side by adding 36 to both sides. Alright, so that's our second equation. Now we do the system of equations. So we'll grab our first equation right here, write that down. Right here. Oops. Okay. So what I'm gonna do is I'm gonna we're gonna multiply our second equation by 2. And then the first one by 42. So 42 to try and like cancel out v2 to find v1. Then we will plug in the value for v1 into one of these equations and solve for v2. So right now I'm trying to cancel out v2. So 42 times 11 is 462 v1. 42 times 2 is 84 v2. 42 times 30 is 1260. 20 times 2 is simply 40 v1 plus 47 times 2 is 94. Okay, that's not even, oops. 36 times 2 is 72. Okay, well, we're gonna change the first one. We're not multiplying it by 42. We're gonna multiply it by 47. Yes, that's what I meant. Okay, 47 times 11, 517 v1 minus 94 v2. And 30 times 47 is 1410. Okay, so we can see that these two just cancel out nicely when you add both of these equations together. Since it's a plus and minus, since they're both plus and minus, so they just cancel out nicely. So both of these equations together, cancel those out. Then 517 minus 40 is 477. v1 equals 1410 plus 72 gives us 1482. Then we divide both sides by 477 to get our v1 alone. That gives us roughly 3.107 voltages. Alright. Then we're gonna want to plug this in. I'm gonna plug it into our first equation. Since our v1 has is the smallest constant compared to the second equation. So 11 times 3.107 volts minus 2v2. Oh yeah, we are trying to find, or I'm trying to find v2 now. We have our value for v1. Now we need to find v2. So 11 times 3.107 is 34.177 minus 2v2 equals 30. We're gonna move this constant to the other side by subtracting it on both sides. So it's gonna be 30 minus 34.177, which is 4.177. Divide that by -2 to have our v2 be by itself. And this is what my calculator gave me as V2. So here are my two values for both V1 and V2.